A farmer wants to etch an area of 1.5 square kilometers in a rectangular file, then split it in half with a parallel fence beside the rectangle. How can he do that minimizing the cost of the edge?
In order to solve the problem, at first we draw a rectangle that represents the field which the farmer wants to delimitate to the half of it as the problem above says. In this rectangle we will have two distances. The distance x and represents the length of the rectangle, the other distance y and represents the width of the rectangle. The problem says that the area of the field is of 1.5 square kilometers, given the fact that the area of a rectangle is equal to the base multiplied by the height, which means that x multiplied by y equal to 1.5 square kilometers. Then we get our first expression, x multiplied by y equal to 1.5.
Also, the farmer wants to minimize the cost of the edges file, so that we have to focus in minimizing L, which means the total length of the fence. That's how we minimize the cost of bordering the fence. We look for the equivalence of L. Therefore, L is equal to x plus x, which is equal to 2x and 3 times y, 3y. That will be the objective function that we want to minimize. L is equal to 2 times x plus 3 times y. So that is our second expression. The problem is that L depends on two different variables, x and y. As L must depend only upon one variable, so we can use the expression x plus y is equal to 1.5 square kilometers is isolating one of them. Example, the isolation of the y is equal to y 1.5 square kilometers divided by x, or third expression. Now we will substitute it in the second expression, so we'll get that L is equal to 2 times x plus 3 times y. This will be the main function that we want to optimize. Now L only depends on one variable, which is x. The domain of the function above will be x, which is greater than 0, because as it is a distance, the values can only be positive. Then we'll rewrite it as L in function of x is equal to 2 times x plus 1.5x to the minus 1. In order to facilitate the derivative, in the first derivative, after solving it, it will get that L in function of x in its derivative is equal to 2 plus 1.5 square kilometers to the minus 2. After that, we get the second derivative for the verification. The second derivative is equal to 9 times x to the minus 3. Now, let's look for the critical points of the function. We take the first derivative and make it equal to 0. So we get that 2 minus 4.5x to the minus 2 is equal to 0. 2 minus 4.5 divided by x to the 2 is equal to 0. 2 is equal to 4.5 divided by x to the 2. 2 multiplied by x to the 2 is equal to 4.5. X to the 2 is equal to 4.5 divided by 2. X to the 2 is equal to 2.25 times. X is equal to more or less the root of 2.25. X is equal to 1.5. As it is established above, the x has to be positive since the distances are always positive. Therefore, the is eliminated and we only use x is equal to 1.5 in positive. It should be noted that this will be the axis with a value in x of the critical point in the function. Then, we do the verification of the value of x is equal to 1.5 in the second derivative to confirm that is the maximum or minimum point. The second derivative of L in the function of x is equal to 9 times x to the minus 3. We write it like this: 9 divided by x to the 3. Then we evaluate with x is equal to 1.5, so we'll get that the second derivative of L in 1.5 is equal to 9 divided by 1.5 to the 3.
We already know that the result of this quantity is positive. It means that in this point the function is concave up, and therefore the critical point corresponds to a minimum. This means that x equal to 1.5 is the minimum value of L. It means that we have to minimize the length of the edge fence that will be used. Next, we calculate the order dimension of the field y and determine it in the third expression, y equal to 1.5 square kilometers over x. And now we have the value of x, so we calculate as follows. X equal to 1.5 over 1.5, y equals to 1. Given those facts, they will be the ideal dimension of the field, so the farmer will be able to minimize the cost of the engine defense. The answer is, in order for the farmer to be able to use the less possible amount of fence and reduce cost, the field will be done as follows. In this side, we use the value of x, which is 1.5. In this side, we use the value of y, which is 1. Then, we can observe that the requirement of the area is fulfilled, which will be x multiplied by y equal to 1.5 multiplied by 1 equal to 1.5 square kilometers. Those are the ideal proportions that will reduce the cost of the fence for the farmer who wants to edge it.